Hello everyone, this is me Arijit back with a new video. Now if you remember in our last video, I showed you how you can train your custom model in TensorFlow Lite. Okay, so we took the example of license plate detection. So we took a custom dataset, license plate dataset from RoboFlow. We trained the model in TensorFlow in Google Colab. Then we converted the TensorFlow model into TensorFlow Lite. And then we exported the model and we actually used that model in our computer to do prediction on like pre-recorded videos. Okay, and we checked that the model is working completely fine. If you haven't watched that video, please watch the video so you'll understand how the training is working and how you can get your own model. The link of the video will be in the description. Also, if you want to use my model on the license plate detection, that model is also available in the GitHub repo. The repo link is also in the description. Okay. Now in this video, we are going to use the model we have trained in our last video in Raspberry Pi 4. So we are going to use that model to do object detection. So in this case, license plate detection using a pre-recorded video as well as on a live feed using a webcam. So we are going to connect a webcam with Raspberry Pi and using that live feed, on that live feed we are going to apply the object detection. So we will see how much accuracy we are getting as well as like what is the FPS we are getting. So okay. And after that, if you remember in a few of our previous videos, I also showed you how you can train your own YOLO V8 model, okay, object detection model. And that model also we tried in Raspberry Pi. So you are also going to compare this TensorFlow Lite model with that YOLO V8 model. Okay, obviously in terms of accuracy, YOLO V8 is better, but in terms of speed, this TensorFlow Lite is better. Okay, and now we have to see what are the major differences and which is a better one to use. Okay, we'll talk about test cases and which one to use in what different cases. Okay, so all these things we are going to cover in this video. Okay, now before we start, if you haven't subscribed to the channel yet, please subscribe to the channel so that whenever next we'll make content like this, you will get update. Now, without wasting any time, let's get started. Okay guys, so let's start with the video. Now, very first thing before you start the video, so if you don't know how to do the training, so please watch this video, train TensorFlow Lite model for custom object detection. You can watch this video and from this video you will come to know how you can train your own custom model in TensorFlow Lite. Okay, so that video you can check if you want to train your own model. And next, if you want to know more about YOLO V8, then there is this series like training YOLO V8 on custom dataset. This video you can watch, and also custom object detection in Raspberry Pi with YOLO V8. This video also you can watch. Both of the video links will be in the description. You can go and watch those videos. Now coming to this video, here at first, like I mentioned, we are going to check the TensorFlow Lite model in Raspberry Pi. Now here I'm going to use Raspberry Pi 4 GB version. I also have 8 GB version, but that I don't have currently here, so that's why I'm not testing on that one. I'm going to test on this 4 GB version, both the YOLO V8 and the TensorFlow Lite. Okay. And next is I already have connected my Raspberry Pi with the VNC, as you can see, but you can also use a HDMI cable for whatever connection you want. One thing very important when you are installing the OS in your Raspberry Pi, please install the 64-bit OS. So let me show you. So I'll open the Raspberry Pi imager. So here when you are choosing the OS, make sure you are choosing you go to the Raspberry Pi OS other. From there you choose the 64-bit. If you install 64-bit, it will be easier to install all the libraries. Okay, so please install 64-bit OS and then you boot into your Pi. You can connect with the VNC and you will get something like this. So to test TensorFlow Lite model is very easy. So here is the TensorFlow Lite GitHub repo. The link will be in the description. I have explained about the file structure in the last video, but again I'll explain in this video. So the very first thing is here, the main thing is this detect.tf Lite file. This is a train model. So in my case, this is basically a license plate detection model, and I have used a custom data set with 400 images. Okay, the link of the data set I'll put in the description. Okay, and also you will find it in the last video. Okay, the custom training video. So this is the train model. This label map.txt file. This file also we need. Here you are going to have the name of the class. In our case, just license plate. Next we have the pipeline file config. This file also we need. And finally, these 3 files and also this label map.pbtx, this file also we need. So these are the 4 files we need in our Raspberry Pi to run the TensorFlow Lite model. Okay, now all these files you are going to, if you are training your own model, maybe it is license plate or something else, you are going to get all these models from that training part. Okay, you can watch that video, you'll understand how you are going to get it. And finally, we have this license plate detector pi. Now this is the file we are going to use to apply this model on the live feed and as well as pre-recorded videos. So I'm just going to explain you this code in this video. Okay. Now I also have explained this in the last video, but till I'll explain you a little bit about it. Okay. So here firstly we are importing few libraries. We are giving the model part, which is detect.tflite. If you are using a different model, keep that path here. Level path is the level map.txt. In my case, I just have that license plate in that level map.txt. In your case, if it is different, put the file name here. Confidence, I have put it 0.5. You can increase or decrease it up to you. Video capture, very important. So here I have a demo.mp4 file. I'll show you the demo.mp4 file. Just give me a moment. So this is the demo.mp4 file. Okay. So as you can see, this is the file I'm going to try, and this video or these images were not in the training set. So these are completely new images, and this file I'm going to try in the Raspberry Pi 4. Okay. This file also you will get in the GitHub repo. Or if you want to use your webcam instead of this demo.mp4, you have to just give just zero. Obviously, if you have only one webcam in your Raspberry Pi. And if you want to use Raspberry Pi camera, then you have to change the code. You have to use maybe Pi camera 2 or something like that. Okay. Next, what we have here is we are using interpreter. Interpreter we need because it is a TensorFlow Lite model, not TensorFlow. So we are setting the interpreter. We are getting the tensor details. We are getting the image height and width. Okay. Next, here we are doing some pre-processing. Nothing special. Again, we are opening that level path. So basically that level map.txt file, getting the class names. Here we are reading one by one while the frames. We are converting like BGR to RGB. Basically here we are getting the frame sizes. We are resizing to the width that TensorFlow needs. Okay. TensorFlow Lite model needs. So TensorFlow Lite model in this case, I think it needs 320 to 320 as I remember while the training. 320 to 320 images. Next we are basically here doing the dimension expanding, okay, to create the best size one. Finally here nothing special. So yeah, and here we are actually doing the prediction. So here using the interpreter we are doing the prediction on the frame after resizing it, and from that we are getting the boxes. Okay, so if you have, it can be multiple boxes. If there are multiple number plates in the frame, multiple boxes will be there. The classes and also the scores, all these things we are going to get. Now we are going to go through those boxes, the classes and scores, and from there we are going to get the y mean, y max, x mean, x max, all those things. So different like the points of the rectangle, and we are going to plot those points. So this part is just for the drawing part. So once you get the prediction, so the boxes, the coordinate of the boxes, the classes and the score, here we are just going to plot that. So we are going to, around the number plate we are going to draw a rectangle. We are going to write the class name at the top, and also we are going to write down the accuracy score or score, you can say. Okay. So these things we are drawing here, nothing special. If you want to change anything, you can change it here, no problem. And finally we are showing the frame. So this is a very simple code, nothing, just we are loading the TFLite file and we are doing the interface. So we are basically doing the prediction. Okay, that's it, nothing special. Now to run this model, and also if you're wondering what is in the save model, so this is basically the PV file. Okay, so basically TensorFlow trained models are there. Okay, so now we are going to clone this repo. Let me just copy this, and I'm going to go to my Raspberry Pi. Okay, and here I am going to clone it. So let me go to desktop, and I'm going to git clone, and here I'm going to put it. Okay, it will take few seconds to clone it. Okay, because there is the MP4 file, so it will take some time. Just wait for it. Okay, so it has cloned the whole repo. Now next thing is we need to install a libraries. Installation of libraries is very easy, as we are using 64-bit OS. You need to install TensorFlow, so you can just do pip install TensorFlow. Okay, and if you do so, you are going to install TensorFlow. I have already installed, so it is not going to install it again. So here I'm using 2.13. Now while training we have used 2.8, but here for the prediction part we are using 2.13, but no problem in that. Okay, this is fine, no problem. Next we need to install basically install OpenCV Python. So you can write OpenCV Python. Again, I have installed this, so I don't need to install it again. Okay, and except that what we have here is, let me check. So OpenCV, CV2, NumPy also you can install, pip install NumPy, I already have installed, and then there is this matplotlib, you can also install that one. It's the same way. Okay, so here I have installed all these libraries required. Okay, you just, if you are missing anything, just do pip install that library and you will get it, hopefully. Next is we are going to run, so we are going to get inside the license plate folder. So cd license plate. Okay. Now here, like I mentioned, we just need to run that python license detector.py and just click enter. Okay, so the name is license detector, but obviously it can also detect different objects. So you just have to change the TF Lite file, and also you have to change that pv text file. Okay, that's it, level.txt file. So, and then it will detect anything else for you. So as you can see the detection here in the screen. So this is how I was talking about, this rectangle and the class name and the percentage. So as you can see, it is doing the detection properly in this video. And also the FPS is not that bad, I would say. Okay, with YOLO V8 it was bad than this, but this is actually not real time, I would say, but still it's good. Okay, and as you can see, the detection is okay here. So you can watch this video, and here as you can see, it is doing the detection properly. Okay, now you may be thinking, okay, TF Lite, it's a very good model, it's detecting it very properly. Now let me show you another thing. So I'll just going to change this license detector.py file, and what I'll do is, instead of this demo.mp4, I am going to put 0 here. Okay, so I'll 0. So what 0 will do, it is going to load the webcam. Now I'll save this file. Now I have a webcam here. This is HP W300 webcam. So I'm going to use this webcam. You can use any other webcam. So I'm just going to connect it with my Raspberry Pi. Though it is not recommended that you, while your Raspberry Pi is on, adding a webcam is not recommended, but still I'm doing it. Okay, now we are going to again run the same file. So let me run it. Okay, so as you can see, this is the webcam, and it is going to load the window very soon. So as you can see, it is loading it. Now if I show you, as you can see, even if you see in the screen, there is no number plate, but still sometimes it may detect something. So as you can see, it is detecting this thing as a number plate sometimes, not in every frame, but in few frames. Okay, this is one thing. Now next thing is, so number plate it will detect correctly. So if I search for license plate here, just some license plate if I search for, and if I just show you some images, I'll have to just push it here and this side. So as you can see, license plate is detecting properly, no problem in the license plates. All the license plate detecting correctly, but without license plate also sometimes it is detecting other things as license plates. So if you see my laptop screen and this whiteboard, all these things is going to detect as number plate sometimes, not every time, but sometimes. Okay, as you can see, so now it is not doing it. So one thing you can definitely do, that is you can change the confidence. So now let me show you nano, and here I'll just change the confidence a little bit. Instead of 0.5, I'll make it 0.8. Now if we run it, now let's see. So again, it will take some time to load. Now if you see it, so now it is actually better than the previous time. Okay, so in this way you may, no, this time also it is detecting. Okay, so we are above 8, above 9 even, it is detecting this as number plate, which is not good. Okay, now coming here, license plate as well, like it will detect correctly, no problem in that one. But as you can see, license plate is more than, every time it's like more than 90%, but sometimes less than 90. But even with 80% also, sometimes it is detecting other things as number plates. Okay, which is definitely not good. Okay, so this TF Lite model is definitely accurate, I'd say. Okay, but like it was like definitely fast, I would say. Okay, so the FPS you are getting in Raspberry Pi 4 GB RAM is not bad, and also we haven't applied any kind of quantization, so it's not bad. But the accuracy is not that good. Okay, in few scenarios where you have very less amount of objects and all the objects are different, in those cases it can be good. Okay, but where you have similar looking objects, it will get confused. So okay, so this is the thing with TensorFlow Lite. Now one thing is I have obviously trained with 400 images only, not a very big size image, not very high number of images. That's also thing, but still with 400 images also YOLO V8 is much more accurate. So now I'll show you how YOLO V8 is performing. With the same dataset I have trained YOLO V8, you can watch my last video. Now I'll test YOLO V8 here. So basically this is my YOLO V8 folder. Again, similarly you have to clone the repo. I'm not going to explain the codes on YOLO V8 because I have explained in one of my other videos. Okay, you can watch that video, link will be in the description. So here what I'll do, I'll just go back and I'm going to do git clone paste. Okay, and again it will take some time to clone it. So let's just wait for it. So in this YOLO V8 you will see that speed obviously will be less, but the accuracy will be quite higher. Okay, so I'll show you. So yeah, the clone is done. Now I'll just go inside this folder using YOLO V8. Okay, and now in YOLO V8 also I have the train model base.pt inside the folder, so you can use that one. So in YOLO V8 to actually run the prediction, it's not that simple. You have to write a command. So the command you need to write is, okay, before writing the command, you need to install few libraries. So you just need to do pip install and then r requirements.txt. That's it, nothing else. So there is the requirement.txt file. You just need to press enter. It's going to install everything for you. So it will make your life easier. Okay. So in my case, it's already been installed, so it is not going to install anything new. But in your case, it's going to install everything for you. Okay. Now once done, what we have to do is we need to write Python. Next, we have to go inside Ultralytics. Next, we have to go inside YOLO V8 detect, and then finally it's the predict.py. In model, you need to give your model name. So in my case, the name of the model is base.pt, and base.pt is actually available in GitHub repo, as you can see, base.pt. So that's available there. You can use that one. And finally, in source, we need to write what the name of the source is, demo.mp4. Finally, you have to write show equal to true so that it will show you the so when it is going to render it, when it is going to do the prediction, it will show the live view. Okay, here. So now let's run it. Obviously it is going to take a little bit more time to load the model, so let's just wait for a few minutes. Okay, it has loaded it. So now as you can see here the detection, so here the FPS is low. Okay, it is not that high, the FPS is very low. Here compared to that one, I think is 1/3 of what we had previously in TensorFlow Lite. But detection is similar, at least here it seems it's similar. Now what I'll do is I'll just going to stop it here. And what I'll do, I'm going to again going to use my webcam. Okay, now to use my webcam, what I'll do is, instead of the model will be same, instead of in source, instead of demo.mp4, again we are going to write 0. Okay, so I'll write 0 and enter. And now let's see how it is working on the live feed. Okay, so there you will get the accuracy better, because similar items as we got on like TensorFlow Lite, we are going to get here also. So we'll check the accuracy here. Okay, so as you can see, it has loaded the frames. Okay, so if you can see here, okay, so obviously the speed is low, so that's why the FPS is very low. But here also sometimes it's detecting different things as number plates, but as per my testing, the number of occurrences will be less. And also if you see, the confidence here is very low. Whenever it is detecting those things as number plates, it's like 0.46, 0.5. Previously it was very high, like sometimes it is 0.8. Okay, so there is no way you can distinguish between a number plate and these other things. But here sometimes it will detect wrong things, but still the accuracy score will be very less. So like maybe 5, 6. So let's just check. Let's just change it here and see. Okay. So as you can see, so it will detect very less, I'd say. And also whenever it will detect, the accuracy score will be pretty much low. Now let's check for the license plates, the images we have captured previously. Even now if you check, I just need to push it a little side here and here. So now if we check, now as you can see, it is detecting the license plates here properly. Okay. And here if you see the accuracy score, mostly more than 80, 50 is also there, I would say. I would not say everything in times it's 80 or 90, but in most of the times it's 90 at least, more than 70, 90, 80. Okay. Okay. And whenever it's detecting something else as number plates, the accuracy score most of the times is less than 50, 40, something like that. So as you can see, 2.9 and something like that. So still we can actually distinguish. So if we like give a, I don't know, threshold of maybe something like 50 or 60, like if you give 80 around, you'll be good to go. Just like chances are less that is going to give you some wrong prediction, but even with 60, 70 also you can go. So this is the difference between YOLO V8 and TensorFlow Lite. TensorFlow Lite, the FPS is much higher than YOLO V8. Okay, definitely we can modify the code so that we can find FPS. So here I actually I haven't tested that, but actually that's possible. Okay, so maybe the codes are given, you guys can actually check the FPS and let me know. But obviously the FPS of this YOLO V8 is lesser, whereas TF Lite is much higher. But on the same time, the accuracy of the YOLO V8 is higher than TensorFlow Lite, at least from the test we did. Okay, so even it is detecting other things as license plates, but the accuracy score it is giving is less, like 2.834 maximum. But TensorFlow Lite on the other side, even with 0.8, 0.9, it is saying that this item is license plate, whereas that item is not a license plate. Also another thing, though it's not about the accuracy, but training YOLO V8 also takes less amount of time than TensorFlow here. Okay, so when I train my YOLO V8 model, I think I trained it like for 30 to 40 minutes, whereas for TensorFlow, I trained it for around 2 to 3 hours on the same set of Google Colab. But even after that also, here as you can see in TensorFlow Lite, we are getting a not that accurate result. So this is about, okay, the comparison. Okay, so from that we can conclude that when you really need a high FPS, in that case obviously you have to sacrifice this accuracy and somehow you have to manage with TensorFlow Lite maybe. But yeah, there is another thing, TensorFlow Lite you can make more faster if you like convert the float 32 to int 8. Those things we can discuss in some other video, that in using that techniques you can actually make it more faster. But again, that will again decrease the accuracy. And obviously if you need an accurate detection, in that case obviously you should go with YOLO V8. Okay. And also from YOLO V8 also you can convert into TensorFlow Lite model, but that's not that effective, because if you convert from YOLO V8 to TensorFlow Lite, I have did it, but the speed you will get is not going to be that high. So the accuracy will be less and the speed also is not that high, so it doesn't make any sense. So the best way is convert to TensorFlow, train a TensorFlow model, convert to TensorFlow Lite, use it if you really want to use TensorFlow Lite. Else go for YOLO V8. Okay, that's better in terms of accuracy at least. So yeah, this is all about. So if you have any queries or if you want me to test something else, so please let me know. I'll test that. I'll try to test that and I'll try to make a video on that thing. So that's all about this video. Thank you. Okay guys, thank you very much for watching this video, and I hope you have liked this video. So please hit the like button and also subscribe to the channel. So whenever we are going to make a content like this in next, you will get the update. And actually we are working on many content similar to this. Okay, so you will get those contents very soon. So stay tuned with us and I'll see you in the very next video.